Never use RTV or silicone sealant in the ductwork going to your DC motors or on the covers, anywhere around the DC motor, and don't let anyone else. During the curing process, gases attack the brushes and commutator, and your brushes won't last long. Axial brush stagger eliminates the ridge that's developed between the paths of the brushes, but it's got to be done correctly. Always stagger in pairs, never individually. Here's an example. A plus and a minus brush arm, they're lined up. Then offset the next pair of plus and minus brush arms, and then offset the next plus and minus brush arms. So they are staggered actually, but they're staggered in pairs, never individually. And this shows a single brush arm that is not aligned with the other brush arms. There will still be a ridge that will develop between the paths, but with these brushes riding the ridge, they will lead to arcing, and all brushes mounted on this arm will be hitting that ridge and arcing. A friend of mine made the analogy that this is like riding the rumble strip on the highway. This problem shows up after running for some time, and as the paths start to groove, the ridge starts to build. That's when you'll see this trouble. This may be identified during the PM by looking at the ridge to see if there's a step in the ridge and that it's not completely flat. This is an example of where that really actually happened. Here you can see on the ridge between the paths, you can see this black marking, and that's where the brush was actually arcing. And if you look right straight through the brush holder, you can see this edge is really actually laying right on, you can actually see the path of the ridge right there. And then on the brush, you can see that wear pattern of the brush where it's been riding that ridge. Now this could also happen not just from the brush arm offset, but also individual brush holders can be replaced sometime during a maintenance event, and they not be aligned properly where the brushes are aligned in the brush path. In other words, the brush might be riding that ridge. So be sure when we look at PMs and during PM opportunities that we see these brushes are not looking like this, and that we don't have any steps in these ridges. Circumferential brush staggering on a commutator is a method some designers use for improving the commutation ability of their machine. You can see this is an example of no staggering, and this is where circumferential staggering is being accomplished here. Circumferential brush staggering increases the commutator arc covered by the brush. By increasing the number of bars covered by the brush, the commutating time increases and the speed of current reversal decreases. Here are the shims that between the holders and the brush arm, and these shims is what is actually accomplishing the staggering. You can see more shims here than here, and more shims here than here. Some brush arms have built-in steps rather than shims. They may have steps on the brush arm, built on the brush arm. The purpose of shimming the brushes in this fashion is to increase the total brush arc, which has the effect of slowing down the change in current direction during commutation. Here is a normal coil going through commutation with a normal width brush. Here is what the change in current direction looks like when there is shimming. The change slows down. To examine this one step further, we performed a neutral test to see if the neutral would be centered in the brush arc. We checked precision neutral of each individual path using the AC curve method, and we did that after running the motor within 3 RPMs in both directions. Our findings were a little bit unexpected. First, the path 1 brush was a little distance from the neutral. There's the neutral, and there's the center of the first path brush. Path 2 was a little bit closer to the neutral position. And 3 was even closer to neutral. Brush path 4 was centered on neutral. So even though we expected the neutral axis to be centered in the total brush arc, it was actually centered at one of the end brushes, path 4. If we need to remove the brushes to satisfy current density requirement when a motor has circumferential brush staggering, we must be careful and remove the inside brushes and not the outside brushes. Removing the outside brushes will change the total brush arc and can affect the brush alignment with the neutral axis. Some outside contributing factors to poor brush performance. 1. Vibration. Check for excessive vibration. 2. Is there overloading or too light loading for extended periods of operation? What's the cooling air? Is the motor running too hot from insufficient cooling? Is it contamination from the air supply, the chemical vapors, paint, or silicone sealant? Power. Ensure that the power operation of the SCR is static power supply. When you do have poor performance and brushes are contributing to that, ensure that the brush grade or current density is okay. Ensure brushes are all the same grade, fully seated, not burned or cracked. Brushes need to be able to freely move in the brush holder. Don't let them stick. Ensure there's proper and equal spring pressure, no weak springs. Brush holders need to be equally spaced circumferentially around the commutator. Brush holder's height above the comm must be the same for all holders. Make sure there's no frayed shunts or evidence of current passing through the spring or the brush holder. Poor performance contributors from the commutator. We want to check the condition of the commutator and the film appearance. Measure the comm profile, the bar-to-bar and the TIR. Check for any mica fins, high mica, excessive dirt, buildup, etching or burning. Is scale on the commutator where the brushes are? Is the slot depth low? We want to make sure our slot depth is a minimum of 20,000 slot depth, and that should be measured during these PM opportunities. Check for burning under banding and shorting between bars. Interpole fasteners should be non-magnetic, and field pole fasteners should be magnetic material.